Okay, we are looking at the end behavior of quadratic functions, and these are parabolas. Parabolas are those graphs that are U-shaped, either pointed up or down. So our U goes up or down, okay? And we're going to see why and what tells us whether we have parabolas up or down, okay? All right, let's talk about real quick just what end behavior even is to begin with. So, end behavior is talking specifically about a graph and looking at the graph at the ends of the graph. So, basically, the extremes. I don't care so much about the middle yet. Okay, I'm not asking for the middle in this. I'm asking what happens at the ends. And our function that we're given will tell us that. Okay, and so we are looking at if we take all of our x values and we keep increasing and get bigger and bigger, like all the way out to 100, what are our y values doing? Are they going bigger, 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 going on up to infinity? So it'd go up, 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 up. Or are they getting smaller and being like -10, -100, -1,000, and going down, 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 down? So our y values would go down to negative infinity. And we would think of the same thing on the left side, okay? So that's what we're considering here. And the way we determine that is the sign of the leading term for our quadratic. So the sign of the leading term determines the end behavior for a quadratic function. Since a quadratic function has a degree that is even, both sides will end in the same direction. So remember, our quadratics have x squared. And so that 2 is an even number. So both sides are going to either both go up or both go down. Okay? We will talk later about end behavior when we are dealing with something that are odd degree, okay? And those are going to go opposite. But we are focusing this lesson on just even degrees, so our parabolas only. All right, so we have two different cases here. The first one is a quadratic that has a positive coefficient in the front. It doesn't matter what number's in the front, but it does matter what sign that number is. So if we had f of x equals positive x squared, our leading coefficient would be positive, and of course that degree is even because it's 2. This tells us that both sides are going up. And in this case, we're going to be looking at the right side first. So in this case, we see that our right side goes up and our left side also goes up. Now let's talk about this notation here. This can be a little confusing. This might be the first time you've seen this type of math notation, and that's okay. Let's interpret what's going on. So this part right here says as x, and the little arrow means approaches or goes toward infinity. On a number line, which direction does x go to infinity? Where do our numbers for our x values get bigger, 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 bigger? That is to the right, okay? So if we go to the right, that's what it's saying. Hey, if I go to the right, this is saying what happens to f of x? And we know that y is the same as f of x. So it's asking what's happened to our y values. Okay, so let's look on the actual graph and see what we can see. If we go to x values are going to infinity, that's to the right. What is happening here with our y value? So what's happening up here? And so because this graph is going up, our y values, as we go to the right for our x's, our y values are getting bigger and bigger and bigger. And so those numbers are going to go bigger, 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 bigger to positive infinity. Okay, so this is saying as we go to the right, our y values go up. Y goes up. Y goes up. Let's see if I can squeeze that in there. Okay. All right, so that's that direction. Let's look at our next statement here. And as x goes to negative infinity, where's negative infinity on a number line? That's going to be going left. So as we go to the left, what is y doing? Let's look at the graph here. So as we go to the left, that's x going to negative infinity, because this is negative infinity direction. what are our y values doing? So our y values are going positive, bigger number positive, bigger number positive, bigger number positive. You can see how it just gets bigger and bigger. So our y values are also going positive direction, bigger, bigger, bigger. So that means it goes to infinity as well. So this is saying y goes up. Okay? So that's the interpretation of all those things. As x goes to infinity, f of x, or y, goes to infinity. And as x goes to negative infinity, that's to the left, f of x goes to positive infinity. This is saying both sides go up. Okay? Let's look at our other version, and this is when we have a leading coefficient that is negative. So we have negative x squared. This is saying both sides go down. So we can see both sides are going down. Again, we don't care about the middle. We care about the ends, what's happening at the ends of the graph. And we are going to assume that if it gets really close to the edge and there's no point there that ends it, that it's just going to keep going, okay? It's making that assumption, and it does that even in your homework. All right, so our end behavior here would say, as x goes to infinity, this is saying right, y goes which way? Well, y is going down in this case. Down, down, down. Okay, and it's getting smaller, 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 and y goes down to negative infinity. So that's what that negative is for, and this is going down. And as x goes to negative infinity, that's left, y goes down. So in the same way, if this is going, y goes down. And again, this is both going the same direction. So to the right it goes down, and to the left it goes down, because this is an even degree. It's x squared. All right? So all of that, let's look at some examples here. Okay, determine the end behavior of the following functions. We have f of x equals negative 3x squared minus 7x minus 1. So we are first identifying our leading term. Our leading term is negative 3x squared. That 3 really doesn't tell us very much when it comes to end behavior. The only two things I'm looking at is the negative in the front and that this is a square, which is what we were considering in this unit, in this lesson. Okay, so if this is negative, we know that we're going to be looking at this type of graph where both sides go down. Okay, so right side's going down, left side's going down. Now, in your problems in your homework, you're not going to have to write out that whole crazy statement with the infinities. Most of the time, it is asking you to fill in what y is doing. It's saying, okay, x is going right. What is y doing? So f of x approaches negative infinity in this. Why? Because we're going down. And then as x goes to negative infinity, that's left, f of x goes to what? Negative infinity, because it's going down. So this is negative infinity to negative infinity, or sorry, negative infinity on both sides. Okay? And as a quick hint, whatever this is for the quadratic only, I want to make this very clear because later it won't be the case, okay? But whatever that is the signs of our infinities here, because that's telling the direction the graph is going down. Negative goes down, positive up. All right, let's look at our next one. F of x equals negative 5x plus 5x squared minus 7. Be careful here because it's tricking you because it's not in descending order. So what is our leading term in this one? It is not the negative 5x. It is positive 5x squared. So this is positive in the front. That means both are going up. Both sides going up, and both are going y values to positive infinity. So up goes up to positive infinity for my y's. So this means as x goes right, y's are going up to positive infinity. And as x goes left, y's are going up to positive infinity. And both of these should be the same because they're just doing the same on both sides. All right, and then we're throwing a little curveball here. So we've got f of x equals 8x to the fourth plus 2x plus 1. So one thing I want you to know is that this end behavior works for any even degree function. So these that we've been dealing with are specifically x squared, but it would apply to any even degree. So x to the fourth, x to the sixth, x to the eighth, and so on. So looking at this one, our leading term is what we're finding first. That is positive 8x to the fourth. Again, we don't care about the 8. We're just looking at the positive and the 4. So positive means it's going up on both sides, and it's doing the same thing because it's an even degree. And so that means the right side goes up and the left side goes up, and that means both of our y values are going to infinity. Okay, so later in the course, we will add on odd degree, but this is the pattern for end behavior for every even degree polynomial.